Here's the learning target. I can use exponents to name place value units and explain patterns in the placement of the decimal point. And we're going to talk about exponents. In 4th grade, you should have talked about exponents like this. If you had 4, and that's your base number, that's your first number, right? But it's to the 3rd power. So here's my base number, my original number I'm working with. Here's my exponent. So this 3 is basically saying I need a 4 3 times. So 4 to the 3rd is going to mean 4 times 4 times 4. So the exponent is basically saying I need the base number 3 times. So if we looked at 4 times 4, 4 times 4 is 16, right? Then 16 times 4. 16 times 4. 6 times 4 is 24. I carry the 2. 4 times 1 is 4, plus 2 is 6. So my answer is 64. So that means that 4 to the 3rd power equals 64. This actually means 4 times 4 times 4. So we're going to do the same thing, but we're going to do it with tens. And yes, I'm adding sound effects so that you focus. So if I were to have, and it might be a good idea for you guys to create a chart like this for yourself and have it at home. Keep it with your math stuff, keep it with your school stuff so that you can look at it when you need it, because we are going to be using exponents for a little bit. So if I were to have a number like 10, right? 10. Well, how did I get the 10? What's my multiplication sentence? What's my equation? My equation would be 10 times what equals 10. Well, I can tell you that 10 times 1 equals 10. So therefore, this is simply 10. 10 times 1 equals 10. Well, what if I have 10 times 10? Well, this is showing me 1 times 1 is 1, 0, 0, 0, and 0. So 10 times 10 equals 100, right? How many tens do I have here? I have 2 of them. I have 1 10 and another 10, or I have 1 0, 2 zeros. 1 0, 2 zeros. So 10 to the 2nd power is 10 times 10. 10 to the 3rd power. I need 3 tens, right? 10 times 10 times 10. So I have 1 times 1 times 1 is 1. and I have 1, 2, 3 zeros. 1, 2, 3 zeros. 3 zeros. It's not 10 an additional 3 zeros, it's I have 3 zeros. 1, 2, 3. Let's look at 10 to the 4th power. So that means, oops, I have 10 times 10 times 10 times 10. I have 1, 2, 3, 4 tens. I have 1, 2, 3, 4 zeros. And I know that 1 times 1 is 1, times 1 is 1, times 1 is 1. So 1. 1, 2, 3, 4. 1, 2, 3, 4. So if I start here where my decimal would be here. I would go 1, 2, 3, and you put your comma. Just like that. So let's look at the last one of 10 to the 5th power. That means I'm going to have 5 tens. 10 times 10 times 10 times 10 times 10. Just like that. So I know I have 1, and I have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. My decimal is here, so 1, 2, 3, 100,000. So looking at this right here, I see a pattern of I have 110, and if I have 110, I don't need to put an exponent. It's just 10. Here I have 2 tens, 10 times 10, which is 100. So that means that 10 to the 2nd power equals 100. If I have 10 times 10 times 10, I have 1,000. That means 10 to the 3rd power equals 1,000. It's the same thing. They're equal. If I have 10 to the 4th power, I have 10,000. And if I have 10 to the 5th power, I have 100,000. When I say equal, I mean exactly the same. Stay with me. 10 times 100. Okay, 1 times 1 is 1. 1, 2, 3 zeros. 1, 2, 3. So that's really 1,000. Or I could say 10 times 100 equals 10 to the 3rd power, because 10 to the 3rd power is 1,000. What if I have 6 times 10 to the 3rd power? I can break this up and say, okay, well, I know that 10 to the 3rd power is 1,000. So I could rewrite it and say 6 times 1,000 equals, or I could simply say 6 times 1 is 6. How many zeros do I need? 3. 1, 2, 3. It's the same thing as saying 6 times 1. Bring my 3 zeros over. Just like that. So using what we've just learned from lesson 1, we could say, okay, I have 3 4/10 times 100. So let me plug in 3 4/10. I have 3 4/10. I'm multiplying it by 100, which has 2 zeros, right? 2 zeros. So the number, because we're multiplying, needs to get bigger. 1, 2.
Thank you, Mom.
Welcome. I plug a 0 in here, right? And now I have to make this decimal match this decimal. So this whole number is going to shift this way. 2 spaces. 1, 2. 1, 2. 1, 2. So I can say that 3.4, or 3 4/10 times 100 equals 340. This is what we were just doing. But let's look if we were to say 3 4/10 times 2 to the 2nd power. Well, remember, 2 to the 2nd power really means 100. It means 100. So it's the exact same thing. What if I have 71 divided by 10 to the 3rd power? 71 divided by, the number gets smaller. I have to move 3 places because it's to the 3rd power. 1, 2, 3. So here's my new decimal. I have to plug a 0 in here. Decimal, decimal, 0, 0, 7, 7, 1, 1. So 71 divided by 10 to the 3rd power is 71 thousandths. I want you to think about the number in 71 divided by 10 to the 3rd. 71 is 71 wholes. There's a decimal here. We just don't put the decimal here. It's just something that you have to remember. So you think of 71, think of that as $71. It's the same exact thing. 71 wholes, 71 wholes. Decimal, decimal. You don't have to have the decimal or the 2 zeros. It's the same thing. It still means 71. 71 divided by 10, I know my decimal is here. I'm going to go 1, 2, 3. New decimal, 0. Boom, there's your answer. So let's look at 2 1/10 divided by 10 to the 3rd power. Well, let's take 2 1/10. I know it's division, so I know the decimal moves to the left. How many times? 3 times. 1, 2, 3. Here's my new decimal spot. I plug in 2 zeros. So my answer is 0, 0, 2, 1. So my answer is 0, 0, 2, 1, which is 0, 0, 2, 1, 21 10,000.